Okay, we're going to do a little practice on Kirchhoff's current law, and we're going to use this same circuit that we've been working on. And so we're going to first start by simplifying it. And so once again, my first one is I'm going to identify that these are in series like this, and that they can be simplified. And we've done this a couple times already. And if you remember, we had 330 ohms, and we had 470 ohms, and they just add together. 330 plus 470 gave us our 800 ohms here. And these two added, because they're in series, to give us 560 plus 220 gave us 780 ohms. The further reduction was then the parallel right here. And if we looked at the parallel right there, these became a single resistance. And because these are in parallel, they don't add. The reciprocal is equal to the addition of the reciprocal. So we had 1 over RT was equal to 1 over 800 ohms plus 1 over 780 ohms. And then when we get that answer, we flipped it, and we can do it. We've did this a few times, but we'll do it again. 1 divided by 800 equals plus 1 divided by 780 equals. I then need to take the 1 over the x. And I ended up with 394.94 ohms. 394.94 is the equivalent to this, okay? So now what we want to do is we want to use that ratio strategy that we learned before, okay? So before it maybe made a little more sense and was pretty reasonable to take this series and divide each one of these by the total to get the percentage of voltage drop that we were getting through here. But now for this current, we got to back this up to the parallel, and once again we're going to take a ratio of the resistance in order to determine how much current would be flowing through these. Okay, so for example, this first one here, the total resistance was 394.94, and 800 of it was here. Okay, so if I go ahead and I divide those, and I get 394.94 divided by 800, I get 0.4937. So that's about 49%. So 49% of the current would flow here, all right? And then obviously, a little more than 50% would flow here, okay? This was given that it was 4 amps is what we were given, so we knew that. So because of the current law, we know that this 4 amps gets divided, and 49% is going to go this way, and 50% is going to go that way. So all we need to do is take the 4 amps, and we need to multiply it by the 0.4937, the 49%. So I take this, and I times by 4. I get 1.975 amps, okay? So this is 1.975 amps. So what is the amperage on this one? Well, you could run through this right here. You could get the percentage. You could take 394.94 and divide it by 780 and multiply it by the 4 amps. That certainly would give you the number here. Or we could use the current law to say, hey, we have 4 amps coming in here. The 4 amps, it has, because it has to sum to 0, has to equal this one plus this one. So we get 4 amps is equal to 1.975 amps, because that's how much flows down here, plus however many amps we have here. All right, how do we solve this? Well, we have to subtract 1.975 from here. So 4 amps minus 1.975 amps is going to give me 4 minus 1.975 is going to give me 2.025 amps. 2.025 amps. And because 1.975 plus 2.02 gives me 4 amps. And that's what the current law says, is that at this node, these have to sum up to 0.